Right, so this is P2 part 2. So we're going to go through the last 5 slides, but the last couple slides just put into words like the last few examples. So we're going to focus more on the examples, but one important thing is whatever your index is, you can write it as an exponent by putting it in the denominator of a fraction. So if I had something like x, let's say the 4th root of x, we could write this as x to the power of 1 over 4. So the index turns into the denominator. If that x had an exponent, like the 5th root of x cubed, this would turn into x. The exponent stays on top. So if it's an exponent, it goes on top. Index goes on the bottom. So x to the power of 3/5. So you can turn it into an exponent. You can also take an exponent and turn it into a radical. They work both ways. The next slide just says the same thing. Index goes in the denominator. The exponent goes on top. So looking at example 17a. So we don't like negative exponents. We're going to start by making that exponent positive and turning it into a fraction. So this would turn into 1 over negative 32 to the power of 4 over 5. So everything stayed the same except we made the exponent positive by making it a fraction. We put it in the denominator of a fraction, turned positive. Now, whenever we have a fraction as an exponent, we want to turn it into a radical to see what we need to do to simplify this. So the denominator becomes our index. So 5 would be the index. The number on top stays on top. That stays the exponent. So we have the 5th root of negative 32 to the 4th power. Now on the side, I'm going to do the prime factorization of negative 32. We're looking for the 5th root of negative 32. We're going to break it down. Different ways that you can break this down. I'm going to say 4 and 8, but you could do 2 and 16 if you wanted to. You'd end up with the same answer. Just make sure you're doing it correctly. So factors of 4 would be 2 and 2. Factors of 8 would be 2 and 4. Factors of 4 are 2 and 2. So we're circling groups of 5 here. Perfect, because I have 5 2's. And because this is negative, that means our answer is going to be negative. So negative 2 would come to the outside. However many 2's we circle, however many circles we have, that's how many 2's come to the outside. So I have 1 circle of 2's, that comes to the outside. So this would be negative 2 to the 4th power. But again, it's 1 over that, because it's just the denominator that we're simplifying here. Last step is negative 2 to the 4th power. If you need to, write it out. This is negative 2 times negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. And 4 times 4 would be 16. So this would be 1 over 16. So just do step by step. First, start with the negative exponent. Turn it into a fraction. Turn your exponent into a radical because it's a fraction. And then simplify it from there. Simplify the radical, do the exponent last. Next, let's look at B. So this, we want to bring back our properties that we did in the first part of the lesson. I'm going to combine my whole numbers together. So this would be negative 5 times 3. And then I'm also going to combine my x's together. When I am multiplying the same base, we add the exponent. So it'd be x to the power of 5 over 3 minus 3 over 4. So let's start by multiplying. Negative 5 times 3 is 15. Now with our exponents here, I'm going to write it on the side to make it a little bit bigger. I have 5/3 minus 3/4. If I'm adding fractions, we need to have a common denominator. So I'm going to multiply the top and the bottom to my first fraction by 4, and the top and the bottom to my second fraction by 3. So this becomes 20 over 12 minus 9 over 12. And 20 minus 9 would be 11. So here I have x to the power of 11 over 12. Now, we add the exponents when multiplying, but because it's a negative one that's second, this would be 5 over 3 plus negative 3 over 4. So that's why it ended up being a minus, just because it was plus a negative. So we technically added them, but it ends up being subtracting because the second number is negative. So this would be our final answer. It should be negative 15, sorry, because it's negative 5 times positive 3. All right, last slide. Let's look at number C. So we want to simplify. We only have 3 A's if we write it out. 3 A's under our radicals. We don't have a group of 9 that we need. So we can't simplify it that way, but we can turn this into a fraction, maybe see if we can simplify the fraction. So we know that the exponent stays on top. The index goes to the bottom. So this would be a to the power of 3 over 9. And we can simplify this fraction because 3 goes into 3 and 9. So this would be a to the power of 1 over 3. So that would be how we simplify. For the last example, we're simplifying. We know that if we have a radical and a radical, we multiply the indexes together. So my index on the one on the inside, when you don't have an index written there, it's implied that it's a 2. So I multiply 3 times 2, which would be 6. So this is the 6th root of 125. Now we want to simplify the 6th root of 125. So let's break down 125. Well, our factors of 125 are 5 and 25. And then our factors of 25 are 5 and 5. So here, we don't have 6 of a kind, but we do have 5 to the 3rd power that is the same as 125. So this is the 6th root of 5 to the 3rd power. Now we can simplify this just like we did in part C, where we turned it into a fraction. The exponent stays on top, the index goes in the denominator. So this would be 5 to the power of 3 over 6, which simplifies to, we divide the top and the bottom by 3. So this would be 5 to the power of 1/2. So we can write it like this, or you could write it as the square root of 5. Either way, these are the same thing. Same with C. You can write it as a to the power of 1/3, or you could write it as the cubed root of a. These are the same thing, because the denominator is the index. That goes out front. All right, that's it for the notes. Make sure you get the notes turned in by the end of the class period, and then the homework for this is due on Monday. If you have any questions, feel free to email me. Have a good weekend.